All right, so when you're adding and subtracting radicals, the name of the game is like terms, okay? So you have to have everything basically be alike. So in order to add two radicals, they have to be alike, which means two or more radicals that have the same index number. So they have to have the same index number, and they also have to have the same radicand. Okay, so the little number in the check mark and the number inside of the square root part both have to be the same. All right, so as a couple of not examples, you can't add something like the cube root of 3 and the fourth root of 3, okay, because those have different index numbers, okay, and you also can't add something like the cube root of 2 plus the cube root of 5, okay, because those guys have different radicands. Okay, so those are kind of your rules for like radicals. So let's look at some examples. So this guy right here, the radicands are the same. They're both threes, and the index numbers are both fives. So these are addable. And then you just add them like how we normally would, right? The coefficients get added, and then you leave the radical and the index number the same. It's saying that you have 3 of something plus 4 more of something. Well, that means you have 7 of somethings. Okay. This guy right here, we can't add these because although they have the same index numbers, they have different radicands. So I'm going to start by going ahead and simplifying this. So 12, I know I can break that into 4 and 3. So then that's going to simplify to 2 times 2 root 3, which is 4 root 3. And then root 75, I can break down into 25 and 3. So that's 5 root 3. And now you can see, just recopying that so they're on the same line. Now we ended up with two radicals with the same radicand and the same index number. So now I can add those and get 9. Root 3 is my answer. Okay, so you just want to make sure you fully simplify them. This guy right here, same index number, but different radicand. So we're going to start by simplifying this. So I'm looking for a number that is a perfect cube that evenly goes into 54. So let's see, 8 would work, right? So I can break this down into, let's see, the cube root of 8. No, wait, sorry, no, 54. 8 doesn't go to 54. That was silly. Okay, perfect cube would be 27. 27 goes into this. So I can break this into the cube root of 27 times the cube root of 2. So that's going to be, the cube root of 27 is 3. So that's 3 times the cube root of 2. 16 I can break into 8. So that'll be minus 2. And then the cube root of 8 and the cube root of 2. So that's minus 2 times 2, cube root of 2. So I've got 3 cube roots of 2 minus 4 cube roots of 2, which is negative 1 cube roots of 2. And there we go. All right, and then this last guy here, so 162. So I need a power of 4 that goes evenly into that one. 81 would work. So I can break this into negative 3 times the fourth root of 81 times the fourth root of 2. So the fourth root of 81 is 3, so that's going to be negative 9 times the fourth root of 2. And then 32, a fourth power would be 16, so I can break that into, let's see, the fourth root of 16 times the fourth root of 2. Fourth root of 16 is 2, so that's going to multiply to 6. Fourth root of 2, and that adds to negative 3 times the fourth root of 2. And there we go. All right, so pretty straightforward when you just have numbers. Again, you just have to make sure you follow the kind of the similar rules. And you've done square roots before. You know how those ones work. It's the same thing. You just have to make sure the index numbers match. All right, now if variables are involved in these expressions, then we just add an extra layer. So if that is the case, then we have to have the same index and the same radicand, just like we did before, but also now they have to be like terms. Okay, so let's take a look at this guy right here. So we're going to simplify this. These are just square roots. So I can break this down into 9 and 2, right? So I'm going to have a 3 on the outside. Square root of 9 is 3. 2 left over on the inside. And then with the x's, I can take 2 sets of 2 out of here, and I'll have 1 left over. So that's what that's going to simplify to. This guy, 50, I can break down into 25 and 2. Square root of 25 is 5, so 4 times 5 is negative 20. Okay, there's already an x squared there. And that leaves me with just a 2x on the inside because that x doesn't break down at all. Okay, and now these two are like terms, okay? So the thing that we're checking for is we have the same index number, they're square roots. We have the same radicand, that's good, okay? And the thing that we need to check for is I need to check that this and this, right? These two coefficients have to be like terms. That's what we're double checking for here. Okay, and in this case, they are like terms, so I'm going to go ahead and subtract these. So 3x squared minus 20x squared is negative 17x squared, and then your radical stays the same. Okay, so then this last guy down here, we've got the same index number, we have the same radicand, but these guys, the 3 and the x, these ones are not like terms, right? 3 and x are not like terms, you know that, right? So you can't add them. Okay. Now, one thing that we could kind of do is because they both have a common factor of the square root of 2x, we could take this and factor out that root 2x and then leave behind the 3 plus x. So that's kind of like a nice trick that you could do. It doesn't actually make this expression any simpler. So you wouldn't do this if you were simplifying. But there are times where you would want to do something like that in the course of your simplifying, like if you had like some other stuff going on in the problem that you could use that to simplify further. But for the sake of this one, we would just leave it that way.